Thank you for joining me. I'm glad to have you here. Today I want us to look at alternative to practical physics. How we can carry out this alternative to practical physics. The basic tips that we need. Now, for this alternative to practical physics, the difference is that, yes, for practical physics, you are carrying out the experiment live. But for alternative to practical physics, the experiments have been carried out elsewhere. Now, the information will be given to you. All you need to do is use your material to make the necessary deductions. For example, if you are given maybe a particular experiment to carry out, the instruments you need, in fact, everything in your mathematical set plus your meter rule, or you can say ruler, and your calculator. Now, you take measurements from the question paper, translate everything. Maybe you use your ruler to do calculation. At the end of the day, it will still be the exact thing that you would have done in the laboratory. Now, this class is specifically meant for those who are preparing to write a GCE. For example, this year, 2024. Now, please listen to these basic tips because they will be of great help to you. The practical alternative to practical physics will be writing. Of course, there are 3 questions. We have number 1, number 2, number 3. Now, you are expected to answer only 2 questions, and you must answer this question within the stipulated time given to you. So you should not waste time trying to answer those things you do not know. Now, in order to maximize your time, that is why this lesson is very much important to you. Now, the exam, like I said, has 3 questions. Number 1, basically mechanics. Number 3, compulsorily, is electricity. And then number 2 can be from light. Now, there are 5 basic topics that usually come out in physics practical. We have the mechanics, we have the light, we have the heat, we have the electricity, and we have the magnetism. Basically, 4 usually come out. So, for this lesson, I want you to pay attention because this lesson will have 4 parts. Do not miss any of the parts. This part 1 is all about the tips you need to get your work done. Now, after this, I'll make the part 2. In part 2, I will discuss how we can take experiments on the first one, which is mechanics. Part 3, I will take some experiments on number 2, and then part 4, I will take another experiment on electricity. So let us go. Now, number 1 tip you need to know is that each of the 3 questions, they have 25 marks, and you are targeting 50 marks. Please, experience have showed me that students if you want to make A in physics, everything starts from practical or alternative to practical, because that one, as you are carrying out the experiment, you are getting your answer there and then. So you from your graph, you can be able to say whether you are passing or you are failing. But I have this video for you so that after watching it, you pass. Now, number 1 thing, that each of those questions will be graded to 5 marks. If they have 25 marks, they will be graded under 6 headings. The first one is your observation. We'll have your graphs. The third one is your slope. The fourth one is your deductions. The fifth one is your precautions. And finally, we have the 6th one, which is your short answer questions. Now, I'll explain each of these one after the other. Now, the observation part, of course, both the observation and the graph they constitute the greater part of these 25 marks. So please pay attention to these observations. Now, the observation starts with the material given to you, ability to interpret the alternative to practical, the information given to you, ability to interpret them, take necessary measurements, and then. Now, in that observation, you will be given a piece of information. Most times, under the information, they will give you scale. Under this observation, it starts with your table. Your table is the first thing. In your table, please ensure that your table is clearly written. Now, each parameter must be written. For example, assuming we have a question from, let's say, elasticity. The first thing you should do is your serial number. After serial number, maybe if you are given a certain length, please, this length, remember you are not carrying out the practical in the hall. All you need to do is record the raw value. Record the raw value. So we have length raw value in centimeter. After recording this raw value, the next one, length, they converted. CONV, converted. Still in centimeter, make sure you put down your SI unit. The next one, assume you are given extension. You put extension. Maybe put down the raw value because the conversion, the scale must be given there. So it is necessary that you put down the raw value, create a column for it, and the converted value of the extension, have the extension here, converted. Please put, of course, this one is measured in meter, this one is measured in meter. So all you need to do is each of these variables, as you reach through, please create table. Your table must be clearly written. Now, number 1, number 2, number 3, number 4, maybe your number 5 here. Make sure their SI units are written. Number 2, you record to the appropriate degree of accuracy. Please, very, very important, because assuming this one is length, let's say 2 centimeter. Next one, let's say 3. The other one 4. The other one 5. Maybe the other one 6. As the case may be. Please be consistent with your DP. Pick up a DP and then be consistent with it. Now, all values read directly from meter rule, from devices, must be recorded to at least 2 decimal places. That is why I have here. This one is 2. If you write it like this, maybe you will fail it. Now I write maybe 2. Let's say 3.1, 4.2, 5.3. Let's say 6.0 or thereabout. If you leave it like this, the DP, you will lose some mark on the DP, and then lose some mark also for inconsistent DP, because this one is 2 DP. So all you need to do is, if your reading is just a 3.1, please add 0 to it so that make it 2 DPs. This one, add 0 to this one, add 0 to this one, add 0 to this one. So with this now, I have my values clearly written. Now, for the converted value, if you have your question, all you need to do is check under it, a certain scale is given there. Please, that scale, if that scale says, let 1 centimeter represent 5 Newton, all you need to do is, assuming this one is 2, and then they say 1 cm, and you have recorded 2 centimeter here, all you need to do is to multiply here by 2, by 5 as the case may be. If they say, let 1 cm represent 5 Newton. Now, having gotten this one as 2, all you need to do is to multiply this one by 5. If you multiply this one by 5, it will give us 10 Newton. So, in that case, make sure this unit is written, clearly written, please, and obey it. I have said 3 things. The first one, create your table. The second one, make sure your values your parameters are clearly written. A third one, make sure that they are written to the appropriate degree of accuracy. And the fourth one, make sure that you are consistent with your DP. So these things, if you complete this table, I assure you, you will get your full mark. Now, another thing I need to talk under observation. Please, those scales given to you, they are not there for being the sec. No, they are there because it has been carried out in the laboratory and reduced to scale. You must use your scale. So that is what all I need to do, say under observation. Now, your graph, for your graph to be reasonable, please, your graph must cover at least 2/3. Your scale, please, your scale, for your graph to be reasonable, your scale must be reasonable as well. So you must choose a scale. Of course, the difference between physics alternative to practical and mathematics is that for a quadratic in mathematics, you will be given scale. But for this one, you are in charge. Pick up a scale. A scale, of course, if you are choosing a scale, please avoid odd numbers. Avoid odd numbers like 1, 3, 5, 7, and all the rest of them. Please avoid them because they will require auxiliary calculation. Pick a scale that will not require auxiliary calculation. If you look at the values you have, then your values will now tell you the type of scale to use. Now, for example, if I am to plot a graph of L on a particular axis, now looking at this, my highest value is 6. Now, if my highest value is 6, that means I should choose a scale that 6 will cover at least 2/3 of the graph sheet. So if the graph sheet is from here to here, now my highest value will not be somewhere here. My highest value should be somewhere above the half. So that, and of course, you don't just finish, you don't just leave your scale hanging. For example, if I have something like this, if I have a graph like this, let's say I am plotting a graph of L L against extension, length against extension. Now all I need to do, maybe if this one is 20, if this one is 10, let's say this one is 15.00, this one is 16.00, maybe somewhere here I have 21.00, and somewhere here I have 30.00. Now if I am to plot this graph, maybe graph of L raw, please, against let's say L converted. Now all I need to do is, for me to choose a scale, look at these values. Look at this one. Under the L raw, my highest value is 6. Now, why choosing a scale? I should choose a scale such that 6 will be accommodated. This is half of the graph. That should be accommodated. 2/3 is somewhere here. So I should choose a scale that 6 will be accommodated somewhere here. Now, do not choose a scale that maybe 6 will be accommodated here and you will leave the whole of this place like that. No. Now, a scale like, let's say, 2 here, 2, 4, let's say 6, 4, 6, and then 8 somewhere here. I can choose a scale like this. Now, under these L converted axis, my highest value is 30. Now, I should choose a scale such that 30 should be accommodated somewhere here. Now, if 30 is somewhere here, now which scale do I choose? And of course, if I start choosing 2, 4, 6, 8, 10, it will not work. Now, it is left for me now to decide. I can choose multiple of 5. I can choose multiple of 10, depending on the values I have. So assuming I choose multiple of 5, I can have 5, 10, 15, 20, 25, 30. You see where 30 is? Just before this. Or depending on the values, you have. Sorry, this thing, I can say 5 here, 10 here, 15 here, 20, 25 there, and then 30. I think it is well spaced. So this is the first thing you should do on that graph. Make sure your scale is reasonable enough that your highest value should occupy at least 2/3 of your graph, please. Now, the next thing I want us to look at is the axis. Since you have been given, assuming, length raw and length converted, if you are to plot this against this, you must clearly state your axis. Your axis must be clearly stated. Now, that is number 2. Number 3, anyone that has SI unit, please put the SI unit. For example, if my L raw is in cm, all I need to do is, this is a centimeter. You write in cm. It has its own mark. Now, my L converted is in cm. I will have to write centimeter here. It has its own mark. Now, always, please, you see here, if they say you should start from the origin, please indicate it here, 0, 0. You must indicate it here. It means that you are starting your horizontal axis from the origin, and you are starting your vertical axis from the origin. That is number 3. Number 4, I will have to say about graph is that your line of base fits, try as much as possible to get about 3 plotted points. Assuming we have this, a graph like this. Now, while placing your ruler, make sure I have about 1, 2, 3, 4, 5 plotted points, scattered points that are plotted. While placing your ruler, make sure that maybe you don't pick one, let's say 1, 2, leaving 1, 2, 3 behind, or maybe choosing these 3, these 2, leaving maybe just like this. No. Make sure if you have 5 plotted points, if possible, try to get 3 on your line of best fits, or 2. In worst case scenario, you can get 2. Just like if we have something like this, I can get this 2. I can as well get this 2. If I should get this 2, this and this. Now, it will aid me so that if I want to get my error in slope, it will help me. So that let the scattered points be evenly distributed. I can as well pick these 2. Assuming I am picking these 2, I will have my graph, I will have it like this. Now, make sure, assuming it is cutting any of the axes, cut it properly. Cut it properly. Okay, that is all I need to say about graph. So I have said the axis must be clearly stated and well distinguished. Your SI unit must be there. I have said the origin must be there. Now your line of base fit, please. I've said everything about your line of base fit. You do not concentrate your plotted points on one side. Make sure it is distributed above and below your line of base fit. Now, the next thing I want us to discuss now is the slope. For your slope to be reasonable, you should ensure a large triangle and not just small triangle. No, we need large triangle. That triangle must be right angle triangle. For example, if I have a graph like this and I need to get my slope, all I need to do is you can start anywhere. Start anywhere. Irrespective of the fact that maybe if your highest value is somewhere here, please, once your line, once you have scale somewhere here, start anywhere. You can just start anywhere. Now I can terminate my slope somewhere here. I can terminate my slope somewhere here. Let it be large right angled triangle. Please avoid using just 2 points. Maybe from here you bring it here, and no, avoid using 2 plotted points, please. Let your triangle be a larger right angled triangle. Now, the second thing I will need to discuss about this slope is that while making your deductions now, slope equals, most times we end up writing slope is equal to delta x, divide the x. Let's say slope change in y all over change in x. Please avoid this. Always use the values on your horizontal, your vertical axis as here, and then against change in whatever value you have on your horizontal axis. For example, if I have this, all I need to do is slope is equal to change in length raw all over change in length. Sorry, you may not be able to see it. So let me clean here. So assuming your slope should be like the slope is equal change in value you have here on your vertical axis. That means L raw all over change in L converted. That's what it should be. So at the end of the day, you place your values and then make your necessary deductions. I'll discuss this. Now, precautions. Even though the exam is alternative to practical, it is assumed it is done in the laboratory. There they will say ask you, state 2 precautions. Of course, you will be given 2 precautions to give. 2 precautions taken to ensure accurate results. If you were to carry this experiment in the laboratory, please be free with whatever you are given. There are measurements using there are measurements that were used. Please always state that you ensure, use personal pronoun I ensured, past tense, I ensured that I noted and corrected error due to parallax. I avoided error due to parallax while taking my readings. From, you tell whichever experiment you are using. Assuming if you are using a meter rule, please be bold enough to tell, I avoided error due to parallax while taking my reading from here. Don't just say, I avoided error due to parallax. No, you must tell us where you are avoiding the error due to parallax from. So if you're taking your reading from the meter rule, tell us, 1, I avoided error due to parallax while taking my reading from the meter rule. And of course, if you want to read, you read directly. You don't read by the side. You don't read there by the side. Read directly on the scale. That is the number 1 precaution. Number 2, you don't just drop your meter rule. If you drop your meter rule, it will not work like that. So all you need to do is, if it is not properly placed at 0, please you shift it. By so doing, what you are noting is what we call 0 error. So I have taken the first one, parallax error. So I avoided error due to parallax while taking my reading from whichever device. If you are answering from number 3, of course number 3 will always give you maybe either voltmeter or ammeter. Tell them I avoided error due to parallax while taking my readings from the ammeter or from the voltmeter or from whichever device given to you there. If you are to measure angle, of course you have a protractor, so you can always say I avoided error due to parallax when taking my reading from the protractor. Now the second one is 0 error. 0 error. How you put it? State it. I noted and corrected 0 error of whatever given to you. If it is this one, of course, like I said, you don't just drop it. If you drop it, you make sure that yes, the zero calibration is reading from the middle. So far from the first position there. So if it's not properly placed, you place it properly. So by so doing, you note and correct this 0 error. So in other words, you cannot say I noted and corrected 0 error of the meter rule, 0 error of the voltmeter, 0 error of the ammeter, 0 error. If you are taking from stopwatch, please, it's still okay. So these 2, parallax error and 0 error, are taken. Now, depending, so you follow me on the other experiment so that I will now tell you the various precautions to state. However, these 2 can go for everything given to you, both parallax error and 0 error. Now, the last but not the least, the short answer question. Now, those short answer questions are very simple. Highest 2 marks. You should be able to answer them, or maybe three marks as the case may be. They might ask you, for example, if you are dealing with length of, if you are dealing with elasticity, they might ask you to state Hooke's law. Please be able to state that Hooke's law and state it correctly. If it's something that requires additional information, please supply that information. If something like force, if you're asked to define force, tell us, yes, force is any agent that can cause a body to move, or if the body is in motion, it can cause it to stop. You don't just stop like that. Tell us the SI unit of force. Tell us if that force is a vector quantity or scalar quantity. These are called additional information. Sometimes there are room for additional information. So please, having explained all these things, we will now look at the practicals, some practical questions. So we will now, this is a WAEC opportunity to practical 3, because the practical question is always 3. So opportunity to practical is always 3. Please join me in my next video so that we can now carry out these experiments and see how they are carried out. So please, for the time being, we have discussed this. If you have questions, feel free to drop the question at the comment section. I will be glad to answer your question. Please, before we wrap it up, do not forget to hit the like button. Tell me how impactful this lesson is.